morning to all. Today we are going to discuss about basic COCOMO model. What exactly the basic COCOMO is and why to use it. As all of us know very well that the overall goal of project planning is to prepare a strategy for controlling, tracking and monitoring a complex technical project so that the results can be achieved within a given time period with quality. The estimation of the resources, cost, and schedule in software engineering effort requires the experience, historical information access, and the commitment for quantitative prediction. But this estimation carries some of the risks. These risks lead to uncertainty. So one must very well understood the project scope, the decomposition or exploration of tasks, and definitely historical metrics are very helpful. So one can use any one of the techniques which are provided for estimation, but this is suggested that at least two techniques should be used in a project. These techniques may be past or single project experience, empirical models, automated tools, functional points, lines of codes, etc. Lines of code is the focus of the COCOMO model. The estimation of cost in a software engineering task is the most challenging job, and one of the best way for estimating the cost of any project is COCOMO. COCOMO stands for Constructive Cost Model. This is basically based on lines of codes. So the total lines of codes decides how much effort is required, how much time is required, what is the cost required, and how much a person can write lines of code in a month. So this estimation is done by COCOMO model. COCOMO was first developed by Barry Baum in 1981 as a model to estimate the cost, effort, development time, productivity, and average staff size. This is basically the hierarchy of cost, uh, cost estimation for a software. This hierarchy consists of basic COCOMO, intermediate COCOMO, and detailed COCOMO. Now we will talk about basic COCOMO. Basic COCOMO model is useful for small to medium-sized softwares. Three modes of development are used here, such as organic, embedded, and semi-detached. These models are used to develop the software and to estimate the cost, time, effort. Time means development time, effort, average staff size, and productivity. When we talk about organic mode of development, this is basically the environment in which a developer works in similar kind of project or similar kind of project, and this system can be, or this project can be the small size, the team is of small size, the interface which is required here is quite flexible. While in case of embedded mode of development, a developer has to work in a strongly tight environment. The constraints are very tight here. If we are required to make any changes in such type of project, this is very costly. Semi-detailed mode of development combines the elements of organic and embedded both. So if we take an example how COCOMO can be used to estimate the cost, development time, efforts, and any other estimation in any of these mode of development, we can see this through an example. For any of the estimation, the basic equations which we are required, we can see here that for effort, we are required A multiplied by lines of codes. Lines of codes are used here in thousands. So lines of codes raised to the power B. It results in per person month. Similarly, we can use the equation to compute development time as C multiplied by effort, which already has been calculated, and effort raised to the power D. Here, A, B, C, and D are the constants. We can see these constants in the given table. So these values are predetermined. You have to remember these constants. So for organic, A is 2.4 and B is 1.05. C is 2.5 and D is 0.38. Similarly, for semi-detached and embedded, these constants are already provided. So you have to remember these constant values. The example which we are taking here for a project which has been estimated to be a 4 million lines of codes. And we have to calculate the effort and development time for each of 3 modes of development. You can also be provided to compute any of the value or to estimate cost, effort, or development time, or productivity, average staff size for any particular mode of development. Here we are taking the example, or I am taking the example of calculating effort and development time for the same problem in organic mode of development. Okay, so as we know that the equation for effort is A multiplied by lines of codes raised to the power B. In this problem, we have been provided lines of codes equals to 4 million. So we can represent lines of codes or 4 million lines of codes as like this, Okay. So therefore, KLOC equals to 400. So for organic mode, KLOC equals to 400, A equals to 2.4, B equals to 1.05, C equals to 2.5, and D equals to 0.38. Now, we will put the constants of constants A and B, that is 2.4 and 1.05. A is 2.4 and B is 1.05. Okay, so effort equals to 2.4 multiplied by lines of codes, that is 400 KLOC raised to the power 1.05. After calculating this value, we have achieved 1295, that is 1295 person per month. So this much of effort is required for this project per person per month. Similarly, we can compute the development time here by using the constant C and D and already calculated effort. So as we have achieved effort, that is 1295, so it will be multiplied by 2.5, that is C. So 2.5 multiplied by 1295 raised to the power 0.38. After computing effort by the constants, we have got the result 38. As I already told you that development time unit is in month. So we are required 38 months for this project. Okay. So to write 4 million lines of codes, we will be required 38 months. Total 30. This is the estimated time. Similarly, you can compute the average staff size or productivity. And if you are provided the salary per person, you can also compute the cost, total cost. Using these equations, you can also compute the same values, the effort or the development time for other development modes also. You can compute for embedded, you can compute for semi-detached, but you have to use the constants carefully. For embedded mode development, you have to use the values. So you have to use the values 3.6 and 1.20. And for constants C and D, you have to use the values 2.5 and 0.32. So this is how you can compute. I hope this work will be helpful to understand the basic COCOMO model, how does it work, and why to use it. Thank you.